Hello. Okay, so let's do a recap of alkene. So we went through the reaction. So all organic compound can undergo combustion. So as long as it has carbon, when you burn it, you get CO2. Hydrogen, when you burn it, you get H2O, referring to complete combustion. Then you have addition reaction. Addition reaction because unsaturated. Unsaturated means it is literally means not full. When you are not full, you can add things in. So alkenes undergo addition reaction, and there's quite a number of them. So first you can add H2. So just a recap. So conditions is nickel catalyst, 200 degrees, H2. Quite simple. Just add H and H. Across, break the double bond, and you put H and H. Quite simple. Next one. It is your addition of Br2, bromine water typically. So bromine water, and you break the double bond, you add Br to each of the C. Quite simple. This is also what we know as a distinguishing test, because it has a color change. So when I do this test on an organic compound and my reddish brown solution turns colorless rapidly, I know that there is an alkene present. Yep. Then the third reaction is the so-called addition of water or steam. So in this case, you're adding H2O, meaning you're adding H and OH. As you can see here, the H goes in, then the OH goes in. So together it's H2O. So this is your third reaction. Okay, moving on. Okay, polymerization. Yes, we will learn polymerization, but we will learn this after carboxylic acid and alcohol. I prefer to teach all the polymers together. So you can let this be first for now. Okay, next. Cracking. We learned cracking already. Comparing alkane and alkene, which essentially is just represented by the word this is a distinguishing test. So similarities, they are both hydrocarbon. Oh, what's hydrocarbon? Hydrocarbon means got hydrogen, got carbon only. Okay, cool. That doesn't tell me much. Okay, they are both flammable. Of course they are flammable. So the main difference is alkanes are generally not so reactive. Alkene on the other hand is pretty reactive. How do I know this? Based on the number of reactions I need to memorize. Alkene got like what, 3 or 4 reactions. Wow, a lot. And you have a distinguishing test. Even the flame itself, whether it's more or less smokier, it can give you an indication, but maybe not that clear. Okay, fats and oil. Oh, why got fats and oil? So let's take a look. So remember the word unsaturated means got double bond, or specifically got C double bond C. Poly, when you have the word poly, it doesn't mean it's the place that you go to after O level. But when you hear the word poly, it means that it is more than one. Usually can be many. Okay, what am I saying? For example, polytechnic. What is a polytechnic? So it's actually a place where you can learn different skills, many skills. Yeah, polyatomic means that thing is filled with many atoms. So that's the idea there. So in this case, polyunsaturated means double bond. Poly means more than one. So as you can see here, this is an example, and you can see that there are 4 C1C inside. Cool. This is just an example. So that's what it means by a polyunsaturated fats or oil. Okay, you will need to know how to manufacture margarine. Huh? How to do margarine? So actually, it's nothing new. It's merely an application of what we have learned. As we have seen earlier, we learned that alkene can become alkane here. 200 degrees, nickel, H2. Cool. So it's the exact same thing here. You notice it is also hydrogen, 200 degrees Celsius, and nickel. But what happens, it changes vegetable oil to margarine. So vegetable oil is essentially alkene, margarine is essentially alkane. Oh, so this is a application of your reactions into your real life context, essentially. What are the difference between oil and fat? I think this is quite interesting. Fats are solid at room temperature. Like for example, what fats do we see in food? Lard. Lard is I think pork fat or something, right? It's like a solid form kind of thing. Whereas oil, vegetable oil, olive oil with palm oil, they are all liquids. So there's the difference. And why is it so? Saturated means no C+C, and it's a solid. This one have C+C, and apparently it's more likely to exist as liquid. Oh, seems to have some trend here. Yeah, that's all for alkene. Okay, moving on to alcohol. So alcohol are basically, they must have the OH functional group. Okay, do take note. Here got this. Your OH functional group it is the name is called hydroxy. So sometimes they will ask you, name the functional groups present. Students will generally say, alcohol. So alcohol is not the functional group. Alcohol is called the homologous series. The actual functional group here is called the hydroxy functional group, which we commonly call it OH. So there is a difference, and it's a very common trap that people have to set for you. So alcohols contain carbon, hydrogen, and oxygen. So you might be wondering, so in this case, it also contains oxygen, which means alcohol is not hydrocarbon, no? Because hydrocarbon is hydrogen and carbon only, ma. Yeah, so their names always ends with OL, all. Ethanol, methanol, propanol, phenol, all. And they have a general formula of CnH2n plus 1OH, which is a little bit harder to memorize per se. Alkane quite simple for general formula, you can remember it. So there's some example here: methanol, ethanol, propanol, butanol. So 1 carbon, 2 carbon, 3 carbon, 4 carbon. Okay, next. So you should also be able to draw the formula. Okay, the formula itself can also be a trap. So you need to be careful of the word they choose. When you see the word full means show everything. That's why it's called a full structural formula. If they don't have the word full, let's say they say, draw the structural formula. So obviously I need to see a structure because it's called structural formula. But note, without the word full, I can just get away by writing this. HHHHHOH. Honestly, you look at it and you go like, got difference ah? Slight difference oh. So if the question asks for full structural formula, you need to show every single bond. If not, you will lose the mark. Yeah, so do take note, this is a trap that they can lay for you. Reactions. Okay, there are pretty much quite a number of reactions. So alcohols are generally very volatile. Why? I mean, very simple. Something that we have been using quite intensively recently. Oh, my hand dirty. I need to disinfect. How to disinfect? Of course, you can wash with soap. But a more common way nowadays is you will take some hand sanitizer and you squeeze on your hand and you just rub. The next thing you know, the liquid no more. My hand is apparently clean and it feels cooling. Because what you are doing is you are actually forcing the alcohol in your hand sanitizer to evaporate. So volatile, this also proof that alcohols are very volatile. Yeah, so that's what volatile means. So a more volatile liquid, volatile liquid means they tend to evaporate. So careful, I'm not using the word boil. Boiling takes place at boiling point. But evaporation can take place at any temperature, not just boiling point. Has the size increased, the boiling point increased? I mean the usual lah. The molecular mass increase, the intermolecular forces is stronger now. That usual explanation, which is nothing exciting. Okay, next, combustion. Again, I like to emphasize that combustion is not a reaction. Okay, it is a reaction, but it's not something unique. You see. Yeah, so it's not something unique. Basically, every organic compound can burn. So it doesn't help you identify much things. It's just, it's something that everybody can undergo. Okay, cool. So when your alcohol has the carbon, so the carbon, when you burn, you get carbon dioxide. Alcohol contains H. When you burn the H, you get H2O. Oh, cool. Yep, that's all. This is a new reaction. Oxidation. So what happens in oxidation? So when it reacts with your KMNO4 acidified. So let's look at how we write the equation. So this is the first main reaction in alcohol. So this is how we write the equation. So combustion means react with oxygen not really oxidizing agent but oxygen. So when you write it out, you write 3O2G is oxygen. But when you are doing oxidation, you are reacting with oxidizing agent. Then honestly, the main problem you will face is that means I need to write KMNO4 in my equation also What does it form very complicated So actually there is a shortcut and this is allowed. It's completely legitimate. Meaning the oxygen from the oxidizing agent can be represented by this square bracket O. Wow, that make your life so easy. So in this case, you can see So you will get CH3COOH. Yeah, very simplistic. So that's how you write equation when the alcohol is oxidized. Yep. In fact, you realize in this case, we expect to see that the purple KMNO4 solution, what will happen? Color change. Remember it will decolorize, sorry. So it turns colorless. Which means this is a distinguishing test. So that you will learn 3 distinguishing tests essentially. One for alkene, the aqueous bromine. One for alcohol, in this case you can see KMNO4 or K2Cl2O7. And third, it's acid, to test for carboxylic acid, which is just acid base, acid metal, so that's nothing new. So this is distinguishing test, and the observations that we should see is purple KMNO4 solution will turn colorless. So this is the second distinguishing test. They will test one at least out of the 3 for O level, so which is pretty not bad. Yep. Okay, so there's actually also a real life use. So it's what we call a breathalyzer. I don't think it's something that is entirely relevant to you now because you don't drive, you don't even have a license. But you may have seen it before happen to maybe your family member or something. So when people, there's a reason why you don't drink and drive, because drinking alcohol can impair your cognitive ability. It can impair how you see things, how you think about things, and it literally also will slow down your reaction time. So don't drink and drive. Yeah. But which means that the police will have to check have to check whether this driver is drinking or not. So they use this breathalyzer lor. So literally they just bring this, ask the driver to blow in, and your breath will betray you. Your breath will actually tell the machine whether you have drank or how much you have drank. So quite interesting. So in this case you can see, it's actually KMNO4. Color change lah. So it's interesting application of this reaction. Yep. Okay, next we have how do we make ethanol? It means the one that people drink. So we're gonna learn it. Of course, we're not gonna do it in the lab. That is a bit no. Okay, so how do we produce ethanol? You have 2 ways. One way is the chemical way or the industrial method. Meaning, I use ethene, I add addition of steam. So that's one way. Another way that more commonly used in a large scale is by fermentation. So it's glucose in your fruits, your grapes or whatever you call it. You will put yeast in and no oxygen, and keep it at 37 degrees Celsius. That's all you need to do, and it will actually generate your sugar will actually becomes ethanol. I guess that's in a sense how you make fruit wine lah, or wine per se. So that's the idea. So it must have a yeast. It must be kept at 37 degrees. So you can actually ask you, why must 37? Why if it's too high? Why if it's too low? I believe you may have learned it even primary school, right? So if it's too high, you will get denatured and you will die. Basically, your yeast will die. And without the yeast, the reaction cannot take place. If it's too low temperature, the yeast will basically hibernate. Also cannot react. Yeah, so there are a few key conditions. 37 degrees, yeast. Yeah, essentially. Alright. Unfortunately, no matter how you do this in terms of your glucose becoming your alcohol, the yield is really, really low. It's at like 15%. Yeah, which means you need to think back to your one of the first few topics. Oh, this is why they need to what's happening. Yeah, you need to use your fractional distillation. Oh, I think we have learned that before, right? Fractional distillation. Yep. I mean, as you can see here, fractional distillation. And do take note, it must be in the absence of oxygen. Yep. So this is an airlock. What's an airlock? Yeah, airlock means you lock the thing and prevent air from going in. Yeah. So in this case, you can see the setup. The lime water is an airlock. I mean, the gas, in order for the gas to go in, the gas need to, imagine with me. So imagine your gas want to go in. It means you need to go in first, dissolve. Once you dissolve, apparently you can go through here again. So it just doesn't make sense. Ridiculous. But that's how your lime water can help to be an airlock to prevent oxygen from getting in. Okay, so what happened? I think I mentioned this before. What happened when the alcohol drinks, you leave exposed to the air? Like your wine, your beer. Oh, my father has a very expensive beer or wine. Sure, but if your parents that forget to close the, I don't know, your cork, your lid or whatever you call that, your wine and beer will oxidize because there is oxygen in the air. And even though here say, a few days, yeah, for a few days is what it takes to fully react, Yeah. So what do we need? We need oxygen, we need bacteria. Interesting. So this is one common way to actually so it must be absence of oxygen. Okay, uses of ethanol. Well, I think it's pretty straightforward. You can use it in alcoholic drinks, solvents, fuel fuel in car, fuel in cooking, fuel. Yep. Okay, we can move on to the next one, carboxylic acid. Wow, that's fast. So carboxylic acid means they must have the COOH group. Oh my god, the molecular formula is so long. Oh no. Yep, a little bit unfortunate, but do have to take note. And for ethanoic, for carboxylic acid, for the name, they will usually end with OIC acid. So let's take a look. Methanoic acid, ethanoic acid, propanoic acid, butanoic acid, OIC acid. OIC acid. Cool. Oh, I see. Cool. Formula wise, let's take a look. So these are some of the whole structure formula. Yep. So actually, I don't panic when it comes to drawing things like alcohol lah, acid lah. Why? So for example, question say question say, oh, please draw butanoic acid. Okay, I hear, oh, butanoic, mother eat peanut butter, but, oh, 4 carbon. So in my mind, I'll be like, 4 carbon. Okay, cool. Oh, it's acid. Acid means COOH. Means straight away I'll just go, oh, 4 carbon. 1, 2, 3, 4 lah. Just simplistic, straight chain, 4 carbon. Acid. Acid is always at the end. Acid means COOH. Oh, that means this shows how I will draw an acid. I will always draw the carbon first. You can't escape, but if it's like propanoic acid, mother ate peanut. Oh, 3. So you must draw the 3 carbon, then you can draw an acid. So that is what I usually do lah. It's very hard to get rid of carbon lah, basically. Next, property of acid. Cool. So carboxylic acids are weak acids. I mean, we learned that. For the most common example is ethanoic acid. Boiling point increase. Again, that usual thing 2 marks they like to ask. See, oh, you see acid bases and salt ma. Oh, weak acid, ionized partially, or that usual thing. Regardless, strong acid, weak acid, it is acid. So whatever reaction that acid can undergo, carboxylic acid should also be able to undergo lah. So first reaction, acid better displacement. Oh, cool. So this is how it is from very, very basic. It's technically reactions that you learn in acid, bases, and salts. Which is a good thing, you know. Can also be a reaction with carbonate. Oh, base. These are the things that you have learned before. Yeah, so these are some of the reactions. Moving on. And write equation lah. Oh, how do we produce ethanoic acid then? Either you can do number 1, a chemical reaction again. So there's a few ways. One is oxidation of alcohol, which we learned like earlier on, as you can see. Or the oxygen in the air can actually help to oxidize. Cool. I would not go into ester. I think it's already quite loaded. I think we focus on getting alkene, alcohol, and carboxylic acid well. That's more important. Yeah. That's about it. Thank you.